We have already completed your first chapter, so called, and even second chapter we will be finishing by tomorrow. Okay. Now back to complex. He says, prove that 1 plus sin theta plus I cos theta upon 1 plus sin theta minus I cos theta bracket raised to n is cos of n pi by 2 minus n theta plus I sin of n pi by 2 minus n theta. As we see that the power is multiplying theta, it is going to be de Moivre's theorem only, and he has got everything in terms of something like n pi by 2 or theta. Let us see how can we simplify this. What is 1 plus sin theta? Do we have anything for it? Sin theta by 2 plus cos theta by 2 the whole square, and cos theta is cos square theta by 2 minus sin square theta by 2. Okay, these are conjugates of each other, yes. So should we multiply and make it square? But then in the denominator what do we have? 1 plus 2 sin theta plus sin square theta plus cos square theta. That is 2 plus 2 sin theta. And will that help us? Because it will be again 2 into bracket 1 plus sin theta, which is sin theta by 2 plus cos theta by 2 bracket square. Okay, we'll multiply. So it will be 1 plus sin theta plus I cos theta bracket square upon 1 plus sin theta bracket square plus cos square theta bracket raised to n. I have multiplied by the conjugate. In the numerator what do we have? 1 plus sin theta bracket square minus cos square theta plus 2y into bracket 1 plus sin theta into cos theta upon, this will be 1 plus 2 sin theta plus sin square theta plus cos square theta raised to n. So this will be 1 plus 2 sin theta plus sin square theta minus cos square theta plus 2i into bracket 1 plus sin theta into cos theta upon, this is 1, so it is 2 plus 2 sin theta. Now this 1 minus cos square theta is again sin square theta. So this becomes 2 sin square theta plus 2 sin theta. So I can write it as 2 sin theta into bracket 1 plus sin theta, right? Because it is 2 sin theta, sin square theta, and again sin square theta. So 2 sin theta can be taken common plus 2i 1 plus sin theta into cos theta upon 2 into bracket 1 plus sin theta bracket raised to n. So 2 is cancelled, 1 plus sin theta is cancelled, and you are left with sin theta plus I cos theta bracket raised to n. But de Moivre's is not applied to this. It should be cos theta plus I sin theta. So we bring it in the cos form. Cos of pi by 2 minus theta plus I sin of pi by 2 minus theta bracket raised to n, which gives us the right hand side. Because then the angle gets multiplied. Cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. You will have to simply mention here using de Moivre's theorem. University, they repeatedly ask us to solve this problem. It is given as if cos alpha plus cos beta plus cos gamma equal to 0 equal to sin alpha plus sin beta plus sin gamma. Show that. First part, cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos of alpha plus beta plus gamma. Sin 3 alpha plus sin 3 beta plus sin 3 gamma is 3 sin of alpha plus beta plus gamma. In part B they say cos 2 alpha plus cos 2 beta plus cos 2 gamma equal to 0 equal to sin 2 alpha plus sin 2 beta plus sin 2 gamma. And C, they say cos square alpha plus cos square beta plus cos square gamma equal to 3 by 2 equal to sin square alpha plus sin square beta plus sin square gamma. It is such a problem, and it becomes difficult as if you have not done this problem earlier, it is difficult to even start with the solution. Can anybody tell me how to start? First of all, it is a problem of complex, so we will have to stick to complex. In other words, we can say that let x is equal to cos alpha plus I sin alpha, y equal to cos beta plus I sin beta, and z is equal to cos gamma plus I sin gamma. This is what we assume, let. Therefore, we get x plus y plus z equal to 0. Because it becomes cos alpha plus cos beta plus cos gamma plus I into bracket sin alpha plus sin beta plus sin gamma. So it is 0. That is given to us. Anything next?
X cube, y cube, z cube, z identity. Then
X
x plus y plus z is equal to 0, x cube plus y cube plus z cube is equal to 3x y z.
You are saying that if x plus y plus z is 0, then x cube plus y cube plus z cube minus 3xyz is 0. 3xyz. Printing mistakes are to be ignored. 3xyz equal to 0. How did you get this formula from? Where did you get it? Expansion of this will contain
x plus y plus z into x square plus y square plus z square minus x square minus y z minus z.
are we talking about this x plus y plus z bracket square first of all? Then
X expansion x cube plus y cube plus z cube minus 3x y z.
expansion contains what?
X plus y plus z
X plus y plus z
into
into x square plus y square plus z square
minus xy
minus
minus
xy minus yz minus zx. But you will have to remember all this. This formula you should know. First of all, we should know that we are to start with this, then this, and then we can go for, therefore, x cube plus y cube plus z cube equal to 3xyz. So this becomes, this is nothing but e raised to I alpha. So it becomes e raised to 3i alpha plus e raised to 3i beta plus e raised to 3i gamma equal to 3 into e raised to I alpha into e raised to I beta into e raised to I gamma. And you will have the expansion on the left hand side as cos 3 alpha plus I sin 3 alpha plus cos 3 beta plus I sin 3 beta plus cos 3 gamma plus I sin 3 gamma is equal to 3 into, this is nothing but 3 into e raised to I alpha plus beta plus gamma. So it is 3 into bracket cos of alpha plus beta plus gamma plus I sin of alpha plus beta plus gamma, and then equating real parts we get the first proof, and equating the imaginary part we get the second proof. That is 1, 2, 3 are imaginary. That is how first can be proved. Okay, what about second? It is cos 2 alpha plus cos 2 beta plus cos 2 gamma equal to 0 to be proved. X square plus y square plus z square equal to what? So you will get cos 2 alpha plus cos 2 beta plus cos 2 gamma plus I sin 2 alpha sin 2 beta sin 2 gamma. But how will you equate it to 0? Suppose I start with x plus y plus z bracket square it will be still x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Even that is not going to help. There has to be some trick, right? What is that? Can I go further and say, as x is cos alpha plus I sin alpha, therefore 1 upon x is cos alpha minus I sin alpha? Yes, it is conjugate of it, raised to minus 1. Now, what is x plus 1 upon x? Is 2 cos alpha. Or you can you go ahead and say something like, therefore 1 upon x plus 1 upon y plus 1 upon z is also 0. Because cos alpha plus cos beta plus cos gamma is 0, minus I into bracket sin alpha plus sin beta plus sin gamma, that is also 0. So this is 0.
LCM being yz plus zx plus xy is equal to 0 of the identity minus.
So what you get here after taking LCM, it is yz plus xz plus xy upon xyz equal to 0. Therefore we get yz plus xz plus xy equal to 0. This is what we got. And then we go with x plus y plus z bracket square as x square plus y square plus z square plus 2 into bracket xy plus yz plus zx. And we got this as 0. This is 0 already because x plus y plus z. So we get x square plus y square plus z square equal to 0. And we get the second one. What about third? Yeah, just use the second one. Cos 2 alpha is what? 2 cos square alpha minus 1. So it is 2 cos square alpha minus 1 plus 2 cos square beta minus 1 plus 2 cos square gamma minus 1 equal to 0. So you will get 2 into bracket cos square alpha plus cos square beta plus cos square gamma minus 3 equal to 0. So equal to 3. So it will be just 3 by 2. Second. Do the other way around. 1 minus 2 sin square alpha plus 1 minus 2 sin square beta plus 1 minus 2 sin square gamma, and it will be again 3 by 2. Okay. So first is important, second is important because of these. Unless we get this, we can't prove this to be equal to 0. And once this is proved to be 0, our job is done. Good. The extension of the same problem, that is, we have proved 3 of them. It is the fourth one. They want us to prove that cos of beta plus gamma plus cos of gamma plus alpha plus cos of alpha plus beta is 0, and same about sine. Sine of beta plus gamma plus sine of gamma plus alpha plus sine of alpha plus beta 0. And this is nothing but this. It is xy plus yz plus zx, or yz, that is e raised to I beta into e raised to I gamma. That will result in cos of beta plus gamma plus I sin of beta plus gamma. Equate real part to 0, imaginary part to 0. So it is just the extension of the same problem. Not the entire problem is asked in the exam, but it could be proved that any one of them, right? Now some problems I will simply explain, won't write them. Let us see if you can do them. It is given that A is equal to cos 2 alpha plus I sin 2 alpha. B is equal to cos 2 beta plus I sin 2 beta. And C is equal to cos 2 gamma plus I sin 2 gamma. Says that prove that number 1, root of A by B plus root of B by A equal to 2 cos of alpha minus beta. Second, root of A by B minus root of B by A is 2i sin of alpha minus beta. Third, root of AB by C plus root of C by AB is 2 cos of alpha plus beta minus gamma. There is hardly anything into this particular problem actually, because if you see, this is e raised to 2i alpha, this is e raised to 2i beta, this is e raised to 2i gamma. Now if you substitute e raised to 2i alpha upon e raised to 2i beta, then it will be e raised to 2 into bracket 2i into bracket alpha minus beta raised to half, so it will be simply e raised to I into bracket alpha minus beta. This will be e raised to I into bracket beta minus alpha. Actually this is conjugate of this. If we understand that, then it is easy. Okay. Same thing goes here. Addition of two conjugate numbers, that is cos of alpha plus I sin beta plus cos of alpha minus I sin beta, will be 2 cos alpha. Okay. So the first one in this, it is LHS is equal to it is better to go with e raised to 2i alpha upon e raised to 2i beta plus root of e raised to 2i beta upon e raised to 2i alpha, which will be e raised to 2i into bracket alpha minus beta plus root of e raised to 2i into bracket beta minus alpha. So it comes out to be e raised to I into bracket alpha minus beta plus e raised to I into bracket beta minus alpha. I will prefer to write it other way around, e raised to I into bracket alpha minus beta plus e raised to minus I into bracket alpha minus beta. That gives us cos of alpha minus beta plus I sin of alpha minus beta is the first one, plus cos of alpha minus beta minus I sin of alpha minus beta, and that sin term cancels and we get RHS, which is RHS. Follow the same steps and you will get the second and third. Over here there is a minus sign, so cos will cancel and sin will add. And in the third one, of course, this will be e raised to 2i alpha into e raised to 2i beta upon e raised to 2i gamma. So it will be e raised to 2i into bracket alpha plus beta minus gamma. It will work out. ते घड्याळ मी वेळेवर ठेवतच नाही. हो, त्यामुळे बरं असतं तर किती वाजलेत कळत नाही. ओके, नाऊ ॲप्लिकेशन्स ऑफ डी मॉरिस थेरम. सो अ स्लाइटली डिफरंट टॉपिक. That is next topic actually. And the problem could be, I will solve one problem and then see if you. Okay. Problem goes like this: solve x raised to 6 plus 1 equal to 0. Okay, so x is अपेक्षित नहीं. So how do we solve this? It's a 6-degree equation and there should be 6 roots, and that too we get stuck up. One option I know that you will start with a cube plus b cube, and if that is your idea, then I will change to 7. Now what will you do? Then I start with saying x raised to 7 is minus 1. But what is minus 1? It is minus 1 is e raised to I pi. Plus 1 will be e raised to I0. I will be e raised to I pi by 2. And minus I will be e raised to minus I pi by 2. So I start with saying this is minus 1, that is e raised to I pi. This is fundamental. Now we also know that cos and sine are periodic and their period is 2 pi. So even if I add 2n pi to it, means I can always say that cos of theta is same as cos of 2n pi plus theta. So I will go further and write this as e raised to I into bracket 2n pi plus pi, where n should take values from 0, 1, 2. It should take how many? 7 values from 0 to 6. Right? Therefore, x will be equal to e raised to I into bracket 2n pi plus pi by 7, where n is still the same. And so we get the roots. N equal to 0. x0 will be cos of n is 0, pi by 7 plus I sine of pi by 7. N equal to 1. x1 equal to cos of 3 pi by 7 plus I sine of 3 pi by 7. N equal to 2. x2 is equal to cos of 5 pi by 7 plus I sine of 5 pi by 7. N equal to 3. x3 will be equal to cos of 7 pi by 7 plus I sine of 7 pi by 7, that is cos pi, that is minus 1. So minus 1 is a root of it. Then n equal to 4. x4 is equal to cos of, it will be 8 plus 1, 9 pi. बराबर ना? 9 pi by 7 plus I sine of 9 pi by 7. You might think that why I am writing all of this, because the roots will be always conjugates. So such a root will not be acceptable, because now it will be 9 pi, 11 pi, 13 pi. Those will be the next 3 values. But none of them are conjugates of each other. This is not allowed. The equation is a real equation. So the complex roots must be conjugates. So we will have to rewrite this in the conjugate form. How would we do that? How do I do this? So I will write this as cos of 2 pi minus 5 pi by 7 plus I sine of 2 pi minus 5 pi by 7. So it is cos of minus 5 pi by 7 plus I sine of minus 5 pi by 7. Cos of minus theta is cos theta, so this is cos of 5 pi by 7 minus I sine of 5 pi by 7, because sine of minus theta is minus sine theta. So I got conjugate of this. Similarly the next one, and those are the 7 roots of it. Okay, got the procedure? So it is to solve, that is what the problems are. This is first one. Second problem will be to solve something like x raised to 4 equal to I. Find fourth root of I. Now the equation is complex, so the roots may not be conjugates. For a real equation, the roots will be conjugates. Third, find cube root of 1 or cube root of minus 1, which will follow the similar procedure, right? So let us not take this. Fifth root of 1 plus 1, right? And then they have some problems like these. X raised to 5 plus x raised to 4 plus x cube plus x square plus x plus 1 equal to 0. Solve. How do we do this then? Because these are all okay. These will fit into this particular procedure, right? Once you get these 4, then you will have to write it as 2n pi plus, and if it is 4, n will be 0, 1, 2, 3. If it is 5, n is 0, 1, 2, 3, 4, and 5 roots. Here, for that, I need some space. I will use it here. What happens is x raised to 5 plus x raised to 4 plus x cube plus x square plus x plus 1. If I multiply by x minus 1, so it is x raised to 6 plus x raised to 5 plus x raised to 4 plus x cube plus x square plus x. It is minus 1 minus x square minus x cube minus x raised to 4 minus x raised to 5. Everything cancels, right? It remains x raised to 6 minus 1 equal to 0. What we have done, we have multiplied by x minus 1 to this. Equation reduces to this, which is our form. Which root we have introduced? X equal to 1. So find 6 roots of this, out of which one root will be plus 1. Skip that, remaining 5 will be the roots of this. There were 5 roots. We multiplied by x minus 1. Equation becomes simpler. This we solve. We get 6 roots. But one root, x minus 1, we have introduced. So x will be plus 1. So out of those 6, leave that plus 1. Rest will be the roots, 5 roots corresponding to this. Okay? करो. Now these are simple. ना? सिर्फ conjugates adjust करने होंगे. You need to adjust conjugates. Without conjugates, मतलब 9, 11, 13, nobody will give you marks for that. Okay? करो.